So in this video, I'm going to go over how to write a two-column proof into a paragraph proof. So let's say I finished this proof from the last video you watched. What I want to do now is I want to turn it into a paragraph proof. So what I'm actually going to do is, let me see, can I have two windows open? I want the presentation part. Nope. Okay. So seeing that I have that proof off to the side, I'm going to make my font a lot bigger. Okay. So what I would do here is if I wanted to turn this into a paragraph proof, I would start off with my given. So I would say given, and I would say AC equals AB plus AB, comma. That's how you always start off a paragraph proof. Then I could say, and the diagram. Then I could say from there that AB plus BC equals AC. Oops, I didn't capitalize that C. By the segment addition postulate. Then from there, I need to turn it into AB plus AB equals AB plus BC. So then I can say using the transitive property of equality. Oops, I can spell equality too. We get AB plus BC. No, AB plus AB equals AB plus BC. Okay. Then my next line, I would say using subtraction, we get AB equals BC. Then you always end a proof with therefore when it's written in a paragraph. AB equals BC. Oops, why do I capitalize things? Equals BC. This is how I would turn that first proof from the other video into a paragraph proof. So I will just number this so you can see that one as I do the next one. Here was the second proof we did. So then I would say, same thing, I would say given measure of, I don't know if your versions of Word have this, but actually, if I go to insert and under symbol, there's an equation. I can type in M, and then up here, if I scroll down, it should be in here. I thought it was. Okay, if it's not in there, then I can do backslash, type the word angle, and it appears. So 1 equals measure of angle 3. So given that, and the diagram, you always want to mention the diagram if it gives you a picture because that's kind of helping you to find your answers. Then I can say measure of angle EBA equals measure of angle 2. Whoa. I typed that wrong. Measure of angle 2 plus measure of angle 3 by the angle addition postulate. Then I want to move on to my next line from the proof. I have that measure of angle EBA equals a measure of angle 2 plus measure of angle 1 by the substitution property of equality. So I would say using the substitution property of equality, we get And to get the equation shortcut without having to go all the way up there, you can press Alt and then the plus equals button, and it gets you this box in Word. Measure of angle. Nope, spell angle right, so it'll change it for you. And then you press space every time after you type the word angle so it knows to change it. EBA equals measure, I did it again, measure of angle 2 plus measure of angle 1. Okay, that is the end of this sentence. And then I could say, using the commutative, words are not my friends today. Using the commutative property of addition, and you need to specify that it's of addition. There's another one for multiplication. I have the measure of angle EBA equals the measure of angle 1 plus measure of angle 2. Then by the angle addition postulate, measure of angle 1 plus the measure of angle 2. Whoa, 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 whoa. What am I doing here? Measure of angle 2 equals the measure of angle CBD. Okay. Then I could say, using the transitive property of equality, measure of angle EBA equals measure of angle CBD. Then, just like before, I want to end my proof with therefore. Therefore, actually, yeah, measure of angle EBA equals measure of angle, no, why do I keep putting that in the wrong spot? Measure of angle CBD. Okay, then what, that already numbered for me. Okay, so I want to move on to the third proof we did in the previous video. This one was my symmetric property of congruence. When it tells me something specific like that, that's going to be my therefore at the end. So I'm going to start off with my given. Given, if I am in Word, I can get those lines above. If I go to accent, and I have to wait for it to load, there's a bar right here, and then I just have to type in there. So I have LM. Then the congruent symbol is definitely in here. It's right here. And then I want to go back to the accent, click on that. And then I have NP. And nope, I want to be out of this window. And the diagram, I can say LM equals NP by the definition of congruent segments. Then I have my next sentence, the symmetric property of equality. So I can say, using the symmetric property, oops, I didn't mean to capitalize that one if I wasn't capitalizing the rest, property of equality, I get NP equals LN. Then by the definition of congruent segments, I get, and this is where I want to go back into my formatting. So if I go to the accent, the bar above, this time I'm typing in NP, and then I want to go find the congruent symbol from the symbols. Oops, I didn't arrow out of that, so it kept the bar with it. And then I want to go back to the accent, get my bar above, and LN. Then I can say, therefore, I want to type my original thing, so, which was, I'm not original, my proof. So I want to go into accent again, NP, and I want to say equals accent LM. It was M all along. Why did I get N over here? Therefore, NP, segment NP is congruent to LM. There we go. Okay. Moving on to the next one. Okay. So start off with what I'm given. Given angle 1 and angle 2 are right angles, and the diagram. I always say the diagram, even if in this instance it's not particularly helpful. I can say that the measure of angle 1 equals 90, and then I believe the degree symbol is in here too. It's not. So to get the degree symbol, I go backslash and I type the word degree and it appears. And then I also have the, I'm going to say and here because it's not a 2-column. Measure of angle 2 equals 90 backslash, type the word degree to get the degree symbol. By, the definition of right angles. Then I can say by the transitive property of equal, nope, I don't want to capitalize these words if I didn't capitalize them in the sentence. Measure of, measure of angle 1 equals the measure of angle 2. Then I can say by the definition of congruent angles, angle 1, and then I want to go up here to find that congruent symbol, angle 2. Therefore, and I can do it again, angle 1, find my congruent symbol, angle 2. Okay. And I think I have one more proof. Yes, one more proof. So the last proof we talked about in the other video is proving the vertical angles theorem. So I'm going to say given angle 5 and angle 7 are vertical angles in the diagram, I can say angle 5 and angle 6 are linear pairs, and angle 6 and angle 7 are linear pairs. By the definition, you know what? I just realized that shouldn't have been congruent segments. It should have been the definition of congruent segments. Definition of linear pairs. This is what it should have been. Okay. Then I can say by the linear pair postulate, angle 5 and angle 6 are supplementary. Sup. And angle 6 and angle 7. What? Why did I not type that in here? Angle 7 are supplementary. Using the definition of supplementary, the measure, I put that in the wrong spot again, measure of angle 5 plus the measure of angle 6 equals 180. Remember to get the degree, I do backslash and type the word degree. And then I also have, and the measure of angle 6 plus 7 equals 180 degrees. Okay, then I have my next line that uses the transitive property. So by the transitive property of equality, I get what? Control Z, redo? Okay, there we go. By the transitive property of equality, I have the measure of angle 5 plus the measure measure of angle 6 equals the measure of angle 6 plus the measure of angle 7. Using the subtraction property of equality, we get just the measure of angle 5 equals the measure of angle 7. Then I can say by the definition of congruent angles, angle 5, oops, I spelled angle wrong, 5, want to find the congruent symbol, angle 7. And here is my whole proof.